Hi all, good evening and good morning. So we will continue the session on data wrangling on Python that we started yesterday. So for those people who may not have joined yesterday, for them in the chat the link is provided to log into here, and the code for today and also yesterday, the cumulative code, has been added to data wrangling code 2 here, or the card you can see, and you can just download it. So it will have the same folder structure there as it was yesterday, with few additional notebooks which I'll be covering today, and a little homework lab. Yeah. And discourse orientation is also present here. And apart from that, it is also in the chat at top. Yeah. So I think I'll resume from where we had left. So yesterday, I'll just give a little bit. Yeah. So this is the code for those people who are new. So first we will navigate to the code. And let me just show you one more time the download part. So you just click on it and this will get downloaded. So I had one copy already. So it will have the one. So you just have to extract it and this folder. And this folder you need to open with the VS Code or your cursor, any other IDE tool that you're using. So inside that, we'll see the notebooks. You'll have up to 6 notebooks and the second lab and the solution for yesterday's lab. It's a small one. So this is in my Windows, but we do development in the Linux box. So this is where the code is present. So I'll just show you here. And before starting, you need to do UV sync so that all the libraries get downloaded. In my case, it's already there. When you guys do it, it will download all the dependencies which you need for this project and create your environment.pnb. That is here, this create.pnb folder that will get created. So yesterday, we started with the NumPy and Pandas, and introduction to NumPy, which is used for numerical Python, and Pandas, which is used for like panel data, like CSV files, Excel files, and reading that row and column wise data, and doing some manipulations on that, filtering, cleaning up. Then we went to rows and columns. How in Pandas panel data we have the rows, and the columns, right? Column labels and row indexes. How we can manipulate them, work with that. So today what we'll see is, so that was the basic part of the Pandas, like the rows, column, minor things. But what more we can do is, one thing is we have to read our data, which is in different format. But there's a possibility in few cases that the data is present across different sources, like different tables or different CSVs, and then you may want to combine them all together into one holistic view, right? Instead of having 3 or 4 different tables, which are essentially talking about the same thing. So if you can combine them, and how would you read them and then combine them together as a one data frame, that will come under data assembly part. Okay, so I'll just start running the code. Yeah. So those who are using VS Code, you will have to select kernel here with the VN Python with this .venv environment, and if you just click on it, it will get selected from here. So Python environments will be listed here, right? So I'll just start with yeah. So these are the 2 repo paths. One is for Pandas for everyone. I think this should be public, and this is also our SV. This is our SupportVectors repo path, where we have stored the data sets that we are going to use, so we can just directly load them from this URL. We already have it, but data files of all the CSV loaded here. I think if you went to the lab, I think you might have seen a bit of that. So let's look at one data set. So this is about Grand Slam winners data set. So here we have 4 data sets, each of which contains the winners for one of the 4 tennis Grand Slams. So in a year, many tennis Grand Slams happen, right? Australian Open, French Open, US Open. So like that, for all of those, we have 4 tables, and which are present in our SQLite database. If you see here, there is a database.db. So in there, we have these 4 tables. So we'll see how using Pandas, we can directly read from SQL, read underscore SQL. Like yesterday, we saw read underscore CSV, right? So in this case, We'll just import it. We'll just connect to our DB, and once we have the cursor. So these are table names, 4. So one is Australia, and Australian Open, Wimbledon, French Open, and US Open. These are the 4 tables containing the winners and I think runner-up also. Yeah, winner and runner-up of these competitions, tournaments between 2000 to 2004, 22, 24, 25 entries total. So each of these first we'll take it as a one data frame. So we are creating a dictionary of data frames where we will store all these 4 data frames after reading from the SQL table, each of these tables. So what we are doing here for table names, or for all these 4 tables, we are iterating over it and data frame. So it is reading from SQL. Select star from table name, the connection we are providing. So it will read all the rows which are present in this each of the table, and then it will add to tournament DF, and the key will be table name and equals data frame. So by the end of it, so we'll have a total of 4 data frames present inside this tournament DF dictionary. Okay. Yeah, so now we can just see whether it has read properly or not from the SQL. So we'll take a few examples, 1 or 2, and see what it contains. So yeah, accessing I think if we are used to Python for accessing a dictionary element, right? We just need to provide the key here, right? This is the dict key, and this will give us a data frame for Wimbledon. Okay, and head. We remember as yesterday, so head will print the top 5 elements of it, first 5 elements. We will just execute it and see. So this is how the table looks like. So it has year 24, 23, 22, 21, 19, and the tournament name is Wimbledon because it is for Wimbledon, and the winner name and who came. Now, if you see the other tables also have the similar structure only. This is the Australian Open, year, tournament, winner. So these column names are exactly same, right here. Only the entries and the year is also same. Only that mainly these 3 things will change here in all of these. The name of tournament. Yeah, but and let us see the shape of all of these. So we have totally 4 tables here, right? 4 data frames here. So we'll just see the size of. So by doing the shape, you can have a look at the rows and columns that it has, right? The dimensions of this data frame. So this one has 24 items. If I run and 25, it has 24 items and it has 25. So totally we have 98 rows and 4 columns. Means if you combine them horizontally, means row wise, after first 25 rows, we add. So there are 2 ways you can do a merging. Means if you have to combine these 2, either we can do it vertically or horizontally. Vertically, I call column stacking. Like stacking. So these 2 tables are there. So one way I can do is these columns are exactly similar. So the ideal way would be if I can just combine these 2 so that it becomes 0, 1, 2, 3, 4, and then 5, 6, 7, 8, 9. So total 9 entries, something like that. So that is the horizontally we are doing. And the vertically other way will be, we can keep it as 0, 1, 2, 3, 4 as it is, only 4 entries. And these columns will come after this. The columns will repeat. So year, tournament, winner, runner, person for team Wimbledon, and then again it will repeat year, tournament, winner, runner. But that is not the correct way in this case. We'll see it later. I'll show you how, because it doesn't make sense. Column names are here, right? Yeah. So what we can do here. So there are 2 things. So whenever data which is related. So if you see here the tournament, 4 types of tournaments are there, and we are repeating the tournament values, right, in all the rows, like 25 rows. All the 98 rows have only 4 distinct tournament. If you say the tournament is like a variable. So if you want, we can also create a common table where tournament is one variable and changing. So we'll come to that later. But before we come to that, we'll see is what are the approaches we can use to assemble this data. So one is a concatenation, and other is called merge. So in case of concatenation, what you do, so as I explained, so there are 2 ways. You can either do it vertically or horizontally. But in our case, horizontally makes more sense in our data. And merging. So merging, I think the people who have used SQL joins, like inner join, outer join, left join, right join. So merge also uses the same feature. And based on a key, the two tables, the two data frames, they will get merged. And there is no access control here. So just like in SQL joins, we join based on key. If there's a common key, so based on that, on those two tables, the common elements will be taken based on the left, outer, inner, whichever it is. So think of merge as similar to that SQL joins and concatenations either horizontally or vertically. If we'll see how these two horizontally and vertically will do and how it differentiates. So there's documentation also present here, so you can have a look at it if you want to. Yeah. So we'll see row concatenation. How do we concatenate it by row? So in case of row concatenation, yeah. So what we are doing here is we are converting it into a list df, and we have four dfs, four data frames, right? Into number dfs for all the keys. What we are doing, this is a list comprehension, so it will get converted into df list. So all the four will become a list, and after that, the list can directly be passed to the concat method. And if you pass it directly without any axis, so here one more parameter is there, axis. So by default, that axis is 0. So in concatenation, you have to remember two things. One thing is axis can be 0 or 1. 0 means row wise you are doing it. Horizontally, you are stacking. And axis equal to 1 means second axis, right? XY, second axis. So along the column, you will be adding it. So this is the row. So we don't need to provide axis 0 because by default it is 0 only. But in case of vertically, we will have to provide df list comma axis 1. Yes. So let's concatenate them and we'll see the yeah. So if you see shape, so when we do row wise concatenation, so the size has become 98 now. And if you want to pick a random sample and check, just do a df and out sample and you'll get one out sample 11 and should points. But let's see the top 5. So you see it has all come here. We'll just not top 5, we are printing top 30 here. And the reason I'll show you why we are doing this. Because we have merged the rows, but still there is one problem. We'll see that. What is the problem? So if we print out first 30, so totally 98 elements are there, right? But if you see the index here, it is 0, 1, 2, 3, 4. But if you scroll down, first table had 25 elements. So up to 24, it's fine. But if you see here, it is again restarting with 0. But ideally, we would, in few cases, we would not want that. We would want all these indexes to be in sequential order and it should not restart after some time. So what we can do here is we can, in data frame, we can just reset the index. And if we do that, so it will reorder them properly. Yeah, so this index, so it is repeating here. So it will repeat for all 4 like this. Yeah, so for a unique, so for that, now we can do a reset of index. So here, yeah, remember this thing is required, drop equals true, because if you do a drop equal to false here, what it does is it will create one more column here, index. But we wouldn't want that here in this case, and in place equals true. In place, yeah, this would also explain like in memory, on the same data frame, the changes have to happen. We don't want a copy of it. On the same, we want to do the changes. So we are just resetting the index and we can print out tail to see the last elements, because then we'll get the idea, right? Whether reset index has happened or not properly. So we have 97 entries. So it is starting from 0. So 0 to 97, total 98 entries. That means the index. So each entry has unique index now. So this is a row wise how we concatenate to if it's a direct concatenation. So more advanced things will come to on the 5th and 6th notebook. But here just a basic idea on how do you assemble. Later we'll use this to do some complicated operations when we want to clean the data, which is in a very haphazard way. So yeah, column concatenation. So I was explaining earlier, so the same df list we can pass, no problem. Only the axis we are changing, axis equals 1. So now what will happen? It will stack those tables vertically, like after the columns, as you see here. Here on a, this is second table, and then this is the third table, and so on. There is a fourth table also. So totally it will have 16 columns, and size will be only 4. Yeah, you can do a shape here after this with the shape. So, but that's how it is. Now we'll see. So yeah, so this is what I was saying. So this type of, so you would want, like, if a table you want to see, you would prefer to have one column as year, like instead of having it in multiple places. So, and this is also not the right way. But if you write any table, you would not be writing it this way. So like the integrity of the table is here compromised because there are two columns with the same name. So if I want to access year, how do I access year? Right? It will be, you can get confused. So there is one thing called verify integrity. So if you're doing operations like this merge, if you're doing on two tables which have completely different columns, suppose we had a second table in which these columns were different, then we could have done this easily properly, right? If we did not have year, tournament, or some column name difference. But in this case, it is repeating. So for that, before we do it, we can also verify the integrity of this, whether my table, so what it does, so it provides us more control. And it will check whether there are no duplicate indices or columns. Because in that case, our table is not proper. So if you execute this, so if I let me just show you here. I'll just uncomment it for now. This has to be commented because this is the error that I'll get. Yeah, so I'm doing the same, so now I'm doing the same operation, but I'm just setting verify integrity equals to. If I do that, in that case, it will show some error, and that is the error. Yeah, so what it says same thing, overlapping values here, tournament. I'll just clear it out. Yeah. So the column and row concatenation part, I hope, is clear, so horizontally and vertically. And indexing. So right now we saw there was a default index 1012 that we did reset also on, but that was a single level. But if you want, you can also have multi-level indexes. So how multi-level indexing will be, like right now only 0 is there, like we have this the example above. So in this table we have here tournament winner and again same thing. So if you see what is distinguishing everything, here is almost common the tournament. Here it is Australian Open, here it is Wimbledon, because based on the tournament only the winner is changing, right? So that is the main identifier here, and the year also. But if you remove tournament here from this from all the tables, so what will happen? Can you identify which? We can't have any uniqueness criteria there, right? What will happen? It will have year 2024, year 2024 for same year. It will have different winners, right? Because yeah. So now instead of doing so for multi-level indexing, so let us see that part now. So we are removing this, dropping this column tournament from this tournament DFs, and after that, if you see from the all tables we are doing it because we are running in a loop, right? So from all the data frames, we are deleting it, and then we are just printing out top 5. Now you see in all the tables, it will be like this only: year, winner, and runner, and there will be conflict now. But now one more thing. So for multi-level index, so this one level index is already there. So if we add one more level of index like tournament, for tournament Wimbledon, these are the entries. For tournament US Open, next. So we'll see. So what are I'm just showing this to, because we have removed the tournament column, right? But still in the data frame list, right, dictionary, we have this information about this Australian Open, to which tournament it belongs to. We already have it here in the keys. So you can directly pass these keys while doing a concatenation. So if you see here, this is the indexed one. Concatenate. So here we can just pass the value. So it will provide a dictionary of all the data frames, and keys will provide all the keys. So based on that, what it will do now? So these keys will, if you provide it, so it will be set as an index. So if you see here, this is the Australian Open. It became an index, and this is a table for Australian Open, year, winner, runner-up. So this way also means at least it is clear, and the data is not repeated too many times. If you want, you can repeat it. We'll see later how, because in a normal table, you want all the entries to have some value. Like this kind of indexing, when you pass an input like to a model for training, in that case, you will prefer means each row has values, some values. But this is just to show that you can do this kind of indexing also multi-level, just not just one level of indexing. So this is how it is: Australian Open, US Open, and similarly for the others also, French Open and Wimbledon. Now, if you have to access it like this so this is a label. So this is a column index here, Australian Open. So if you have to access it, you can directly access it using df name and Australian Open, and it will give you all of it. So this is our data frame indexed. So remember we used .loc. So this is Australian Open. This is the name of the index, right? So if I do had top 5 elements, so it will print out the top 5 elements of the Australian Open. If you see 2024, Jannik Sinner was the winner. So here also, Jannik Sinner. This is for the Australian Open, first one. Similarly, we can see others also if you want to see. Yeah, so this was about multi-level indexing. And the other thing is merge. So the main two topics that you should remember, apart from this multi-level indexing, is concatenation and merge. These we'll be using a lot. So merge. So merge as so those people who are comfortable with SQL or have worked with SQL structured query language in past, they will have some idea on this inner, outer, left, and right kind of joins that we do on two data frames. So if you have, yeah, so we can see this here. So what is the inner one? So this is first one that is the inner join. But for those people who are not comfortable, so I'll just explain it briefly to give an idea on what happens. So in the case of inner, so use intersection of keys from both left and right data frame. So from both the data frames, right, whatever the intersection, whichever keys are matching on both, so they will be taken. So it will keep only rows where the join keys match in both tables. If they match, it will be kept. If they do not match, that row will be dropped. So this I'll show you in the example, and then outer join. So if you remember the mathematics also, like Venn diagram. So this is like a Venn diagram only. So in that, this is the intersection, and if you do a union, you take all the items, right, which are unique here in the sense df1 and df2 both contains and the common also. And in case of left, so it will keep all the rows from both the data frames and fill in NaN where there is no match. If there is no match, it will be NaN. But it will take all the entries from both. And if you do a left join, so it uses the keys from the left data frame, means whichever is the data from the left side, from that it will keep take all the keys, and it will take the matching rows, whichever rows match from the right table, only those will be taken and others will be discarded. And right does the opposite. So it will keep all the rows from the right data frame. If you see this df2, that fourth diagram, the right one, so everything from left is taken, and the matching, whatever matches with the df2 and df1, that will be taken, but the remaining part, if you see this white part in df1, this will be ignored. Same here. So we'll see in inner how it works. So I'll just show you how it can be used, this merging part. So these are the 4 operations on merge you can do. And we'll see how these impact. So yeah, we'll see. So like, and default merge. So default, if you do not specify any merge, right? So it will be inner merge only. By default, it takes the inner merge. So now we are taking 2 data sets. One contains a list of
Ravi, I think you need to run the second block of code, that is import pandas wala code.
import pandas.
That code you need to run, that you have missed. Go to the top.
Okay, I have okay. Okay, this
That
is
you
right.
have missed. The first one, the first one.
First one at top.
Go to the top. Yes,
Okay,
yes,
thank
yes.
you. Thank you.
Now this will work.
Yeah. Now, okay. That was yes. Maybe I'll do one thing. I'll reach here and I'll run all. Indexing, yeah, merge. What I'll do, I can execute all the rows on top. It won't take much time anyways. Yeah. Hello. So now you can see, so that we are taking two tables here. One is players and other is winner. So we'll just convert these to CSVs, which we are converting into data frame, right? pd.read CSV. So let's have a look at these players and winners. So the first table, it contains player and country, means who was the player and what is the country of origin. So she is from Spain, Serbia, like that. For each, this is the individual entry, right? Unique player entries here. And now second is we are taking a winners table. So it has which year who won, right? Year and the player who won. So now if you see, if you want to get details of country also here, if I want a common table or common data frame which contains country also, so then I can do a merge. I can do a merge of these two. So how will the merge happen? So merge will happen on the common field here. So this is the common field in these two, right? The common key player. So when you do a merge, it will happen on the key, the column key player. So and we are doing here inner, right? So the common to both will be taken. So I'll show you the winner when we do this. Yeah, merge. Yeah, so this experience is about them. Let's merge and see. So how does the merge work? So in the case of merge, you have to pass the first one, player df, and then winners df on player. So we are doing inner. So we are joining player df with winners, and the key will be players, which I explained earlier. And if you run it, we'll see the outputs here. So yeah, we'll see this in detail so that we can understand the concept here. So if you see here, the entries are 0 to 10. Right? And if you see here, the year 2010, 11, which one is missing? So what will happen in inner, right? The common elements will be taken from both. So if you see here, for each of these, so here total are 11 entries. But if you see 11 entries, one is NaN. So this key will not match with any of the key here, right? So this table 2020, this will not be present there. But for all the others, so it becomes 10. So if you see all the others, for them, there is a match. Novak, Roger, 1, 2, Andy, Murray. So all these names are present here. So that's why totally we have 10 entries. For each of them, the country will get appended. And because we are in inner join, right? So instead of 11, we have 10 entries, and that so means 0 to 10 entries, not 0 to 11, because any n is not present here. And here, if you see in the results, these two entities will also not represent Daniel and Alexander. The reason being because in the winner DF, right, these two are not present. But all others will have the country here. So we'll see the result. Yeah, that's why it has 0 to 10 items. Otherwise, if we had some value here, maybe the last two options that we have, Alexander or someone, then this entry would also have come. This is like how inner join works. So similar to that, and the format of using it, the syntax, it is exactly same only. The only thing will change is on based on your keys. And other thing you'll add here is you're doing inner, so you're not providing anything. But let us see how we do outer. If we do outer here, we have to provide how. So it is just similar to the SQL joins. This will do the outer join, and you can see here it's rows with all the players from both the different are added. Then the left join, this is also everything is same. Only the thing we are changing is how to do it, on what to do it. And this is right join. So you can later see the results and yeah, compare your understanding on this. If the SQL joins, if you are not comfortable with, yeah, I would really advise to go through it. Yeah, apart from that, yeah, these two merge. So there is one more method called join. So just a little low, just so that you should know that there is one more possibility here. But it also does a similar thing to merge. So, but difference, if you see that between these two, join and merge. So here we are providing pandas, merge, and df, and the other first df and the second df which we are joining, and on key here, right? But in case of df join, how it works is we will have the first data frame that we are joining on. That first data frame dot join, and the other one, the second, the other. And in this case, what we have to do is, if you're passing it and we are joining on a key, in that case, set index, we have to provide this set index key that has to be done. So this is syntax wise, so the difference. And other difference is with merge, the indices get reset. If you see here in the merge, right, we have done merge here. So if you see the indices are 0, 1, 2, 10, 11, so they are all in sequence, right, properly. But in case of join, these indices will not get reset. If you do join here, if you see, so this entry is 0, 1, 1. So it is taking from all the tables, right? Different tables. So this is the only thing here. And yeah, and merge validation. So we've seen the merge part. So in merge, that in SQL joins also, if you consider SQL tables, right? So there are few things to consider, like the relationship, how two data frames are connected to each other. Like we have players. Let me just show you here. What is it we are talking about here? The relationship part. So if you see the tables, yeah, these are two tables. Yeah. So here, if you see, all are unique here, right? The players are unique. And here, if you see, the players are not unique here. And we have to see the relationship. So if you see Rafael Nadal is present here one time. So if you have to join this table with this, right? How will it be? So it can have one-to-one relationship. So there's possible in few cases what will happen, we will have one player and it will have only one entry. But here for Rafael Nadal, it has one. How many entries? For Rafael Nadal, he has one. There's only one. But for Novak, yeah, Djokovic. So for him, if you see, there's only one entry. But for one and 1 to m, so there's repeating, right? So the relationship between these two tables is 1 to m relationship, right? Not 1 to 1. In this case, we'll have one, but in the player tables, we can have n number of same entries, right? Same keys can be repeated. So the relationship we have is 1 to m, not 1 to 1. So now if we are, so just like we verified the integrity of concatenation earlier, like the row and column part, similar way, we can just do a join and we can specify this merge. Yeah, where I was in merge. Yeah, validate merge. Yeah. So here also we can add one more thing to us to validate. Like before joining, if you want to make sure that means what our expectation, because in this case tables are small, right? But in actual case the tables will be too huge and you will have idea, because you will, when you're creating table, you will know whether it is one-to-one mapping, one-to-many mapping, or other. So in this case, if I give one-to-one mapping and I'm just doing a validation here, right? So if one-to-one passes, then only the merge will happen. Otherwise, merge will not happen. It will throw some error, and we'll see that part here. So in one-to-one case, it is throwing an error because it says merge keys are not unique in the right data set, right? Which one is the right data set? Left data set is players. Players, it has all are unique, but in winners they are not unique. So this is left and right. Okay. So second one is right. So it is saying in the right data frame, in the winners data frame, all the keys are not unique. So that's why we cannot do one-to-one. But now let's go to next. So these are so similarly we can check for these either 1 to m, m to 1, or m to m. Like if both have multiple keys, both the table left and right table, then m to m. If the left has multiple, then m ratio m to 1. And if the left has 1, then 1 to m. So that is how it is. But in our case, we just discovered that we have 1 to m relationship, right? Because the players, only one entry is there, the unique players, the winners we have multiple, so 1 to m. So if I pass validate as 1 to m, then only it will pass. Otherwise, I can skip it, but it's good to have it in production, kind of normal, to verify it once at least. So now it has passed. The reason being, because I provide a right mapping, and I'm doing a validate before merge is happening. So, yeah, so this is it about concatenation and merge on data frames, Pandas data frame. Okay. So now let's go to the next one. So if there's any doubts here, I can take it now or later. Yeah, but let me, I think, go to the next notebook first. I hope this is clear. The main things you should remember here for assembly, concatenations, horizontally and vertically. We have axis control there. You can control that by axis. The second is the merge. we can merge. Sorry. And for that, similar to SQL joins, just think SQL joins and merge are similar. We have four things: inner, outer, left, right. Those kind of joins just corresponding to SQL joins. And based on that, the merge will happen. So it is not like horizontally or vertically. So a few times tables will get increased vertically also, but and horizontally also, right? If you are doing a merge, sometimes the table size will increase, sometimes it will reduce based on what kind of merge you are doing. So it's not like only horizontal or only vertical. That control we have in concatenation only. Okay. So next is the string manipulations on it. So now we have seen the assembly. So we have assembled data, everything's fine. Now we have one combined data frame. But on that combined data frame, there is a possibility that few things may want to segregate in from one column to two, three columns, right? Or we may want to merge. Suppose we have three columns, like day or date. Like date, we have day, month, year. Three things are there. Suppose these three things are distributed in three different columns. Then now we need to combine them together. Or suppose if you want to take a date which has date and timestamp both thing, and we want to separate out date and time into separate columns. Right? So we'll see that part, the next two notebooks. I'll go to the next one, which is the string manipulations in pandas. So before we go to that, let us first see the storing text. Means usually how will you store in data frame? Yeah, so pandas. So two important pointers in pandas are, one thing is pandas.series and second thing is pandas.dataframe. Series we don't use that much because series, but all the data frames they are all combinations of series only. So we'll just show you in one example with how it is stored. So usually if you don't define any data type here and you just create a pandas series, so what will happen? So it will create an object type instead of ideally it should be string type, but by default it creates an object type. But it is advisable to use string data type because there are few minor differences in behaviors here and there. Not very major differences, but few are there. So we should provide the string d type here, or we can directly write a string also, d type string, or so now it will become string. Yeah, and this for this references, yeah, you can go through this link just to make you curious about it. Okay, why is it? Yeah, so now this is this one part. So when you're declaring using string, so prefer to provide this string also if you know it's a string type. If it is not a string type or you don't know freehand, then it's fine. Then you can leave it. But otherwise, if you know it is string, use string type. So now let's see, how can we use this string? So for any of the string methods in pandas, right? If you want to use string methods, you can use this accessor .str after that, after the data frame, and then some parameters, and on that parameter .str, we'll see how that like if you take the column names. So we have data frame, we can do data frame that dot column names .str, and after that two lowercase or anything. So I will see that next. So for this, we'll just take one data set, which is a weather data set. So it provides some information about the weather in different parts of the world and historic, the climate information, how the climate has changed. So for the exercise, what we're doing is we are taking a subset of data collected from the New Orleans lakefront airport station. Okay, so we have taken one station, and for that we are taking few parameters. So column names, this is the average daily wind speed. Second is precipitation, and this is Tmax and Tmin. What is the maximum temperature and what is the minimum temperature of that day at that place, at that station. And so we'll just load it from here in the repository. And yeah, one more thing. So if you have to access, and we have provided a few lab homework, right? So in that also, similar way you have to access. So if you have to use any of the CSVs, right, a data set that you want to use. So for that, you just give the SV path and the file name in this format, and you can just load it. So in the labs, I think you might need to use it. So I'm just pointing it out. Yeah. So we are just reading the CSV. And once we have done, we are just looking at the top 5 elements here. So if you see the top 5 elements here, you can see. So what is a station name? Station name is fine. The other thing is the name of the station ID. I think this is ID. And this is the place. So New Orleans, Lakefront Airport, and LAUS, comma LAUS. So it has these two components. This is the country or the state, and this is the place. And if you see your date is okay, 0101. It seems to be formatted properly. You can see the type later. And these are the values, few of the values. Now let's see. So one more thing is here, if you see commons, so the string manipulation is what we are looking at right now, right? So what we can manipulate here. So one thing, if you see the column names, station name, they are all in caps. So we can either make them in smaller or we can capitalize them like S capital and remaining all small. So for that, how do we now access that string part of it? So what we'll do is we have the weather data frame, right? Weather data frame dot columns. So we'll get access to all the columns. And this is the accessor that we need to use, str. After the column, str. And then the functions are available to us. So dot lower, if you do, so it will just get converted into lower. So these methods are already present. And this is a capitalize. Like if you capitalize the first one. If you see the outputs here, it is small. And if you see here, the first one is capitalized. Now this looks okay. So now what we can do is we can change our column names, right? Yeah. So what we are doing, weather df dot columns. So columns had the values, the early values. So those will get replaced by the new columns. So we're just resetting the column names to the modified names. And now we can see whether it has changed or not. Yeah. So one thing is done, right? So this is how we can access the columns and do some string operations on that. Now let us see the next component. What else we can do? Yeah, one more thing is to look at shape, means how many, if you want to know how many entries are present here, right? So you will just do a shape here and it will give you the rows and columns. Sorry. Now if you see here the name. So if you want to break this into two columns, you can do that, right? You can take the first part and then LAUS, you can do this also. We'll do it later, we'll see. So now we'll see how do we split. Yeah. So the station name, yeah, this is what we are doing here. So name and state. So this is the station name, right? New Orleans, first part is it, and this is the state. So we can just break it down into a separate one. What we are doing here, we are taking the weather df dot name. Name is a column dot string and split on comma. So like a string split, if you are aware of the splitting, right? How do you split? So if there's any comma, it will split the text around that. So it will also do the same thing. So what we are doing, name state df, we are just creating one df out of this name. So like it's just like a series. Think of it as a series only. It has only one series. Yeah. So we should just print it out. So what we are getting out of here. So what we are doing here, we are just taking the name column out, right? First we are getting the name column out, and then we are splitting these entries into two on this, because we know this comma is present everywhere on all. So we can split on this. So then we'll, yeah. So when we split, so in this we'll get two entries, right? Instead of one. Now we have separated out these two parts. Now what we can do? Yeah, if you want to print, so all the entries here in this case are the same only for one station, I think. So whatever we print, whether 0 to 61, it will print the same thing. So we are just saying, if you want to access any of the element here, so access the first element, so you can see just two elements. Now what we can do, we can expand these actually directly. So right now it is part of one column only, right? Only one in one column. These two entries, it is separated by comma. These are not two separate columns. Now, if you want to expand this list into from 1 to 2, so all that we have to do is, this is the name study, we are assigning it. So dot name dot string, we were splitting it earlier, right? So we are splitting on the same thing. But what we are doing here is we are expanding. Expand equals true. Expand, what expand equals to does. So if we have one column and suppose if we have to convert that one column into multiple columns, in that case we will do expand, and for that we have to break it also. So now let's see here. So these are a few things that syntax is that if you remember, it's good. Like expand, and it's intuitive also. If you think like expand, like we're expanding from one column to multiple, but we have to split it first here. So if you see here, so these two things, right now they have become two separate entries. So it is 0, 0, 1, these two are divided. So that's how you can split the columns if you want. Because right now we have taken only for one station, right? But there's a possibility that the whole data set will contain for different stations and it will be in different states. So if you want to filter by states only, then now it is easy, right? If it is LA or US or if it is some other state in US, in that case, if you want to filter only LA US, you can filter on the column easily. But if these two were together, it would have been a bit complicated. We'll have to use some regex. Yeah, so now what we can do, so we have these two columns, right? For one column, we have broken down into two columns using the expand and split, right, from string. Now this I can take this column and 0 and 1, these two columns, and add these two columns to my original table, right? This table, and delete this. That is one option. Other option is just replace it with a name and add one more column. Correct. Name, I'll replace the first part and I'll add one more column as state, and that will be LAUS. So that's exactly what we're doing here. So if you see, after expanding, we are taking the 0. From this data frame, we are taking this 0 column label, this 1 column label. 0 will be, so this name will get replaced in the weather data frame. We are replacing the name with this new data frame and states with the first part. Now let's see after that how it looks. So this name, so the name column earlier entries are replaced now, and the new state has been added here. Okay. So that is the one component, and it has these rows and columns. Now let's do something else. Yeah, one more thing. There are a few tricks. We will come to know those tricks. Yeah. So here, if you see, one more thing is if you want to replace, in this case, we are taking this state now, the last column that we have added, like LA is, it is Los Angeles, people know it, but in some cases people don't know it. Want to expand it, or want to replace only this LA in all the rows, right? What you can do is you can first take this row and then do the kind of operation that you want to do. So we'll see what we can do. So we are taking this weather state, okay, and we are trying to replace LA with Louisiana. But if you see here, in this case, it won't happen because there's a trick here. So the normal, if you do that, is a replace function. So it does not make a literal replacement unless it's specified. If you specify it using a regex, so you have to specify like replace comma regex equals true. Then only it will do the replacement. So people may think sometimes, oh, why is it not working? So there's a reason for that. So, and that's why for a replacement like this, we should use regular expression, regex here. And regex, I think people, if you may know, if you may not know, regular expression is like a shorthand way of describing your data, how it is present. So and this is one HTTPS regex101.com where you can start learning and play if you want. I think regex people may know most likely. Yeah, so this is one link where you can play with it. Yeah, so what we're doing here is, so only thing we are changing here is we are making regex equals true. Now the changes will take place. And this is LA. LA is a constant here, but we are going to replace Louisiana. So this part, you should remember that you should provide regex equals true. Otherwise, the replacement, the dot replace will not directly replace. So this is a trick thing. We will see later more about the regex. Yeah, and now if you have to concatenate, join two things on string concatenation only, right? So in this case, concatenation joins two columns of string data type using specified separator. It is done using .cat method. If you have to combine these two columns together, again, the name and state that we had separated earlier, right? So now we can combine them also into one column together. That's how we are doing it. So we take name dot weather name dot string concat cat whether df state, and what separator you want to use. So we are using comma and space. So if you see comma and space here, because this is separator being used for concatenation of these two columns into one now. So this one column has been created. Now station name again. This is a string concatenation, but in case of, yeah, but normally string concatenation, if you do, we take only one string, right? But in this case of Pandas data frame, so that is the main thing. Like it will operate on the whole series or the whole column, all the elements. Yeah, that's, yeah. So this is concatenation. I think this is fairly simple. Yeah. The other thing is extraction. Suppose if you want to extract few items, like if you, yeah, in few times, right? What happens is you have a splitter. Like if you want to split any text, you will have some identifier like comma, underscore, full stop, colon. That's right. Based on that, you can split. But suppose in cases you don't have that, you have no comma. Suppose in this case, like we have cases guinea. So cases underscore guinea. So I can easily using string split, I can just split it, right? And I can separate cases and guinea easily. But if you say the other thing, cases without underscore, so C caps, G caps. Now this split functions cannot be used, or we'll have to provide some regex here to do it. So that's what will happen now. So in extract method, so this is what we do. So what it does, it will accept one regular expression. And in regular expression, actually, you can provide some groups. We'll come to that now. Like if you see here, if you take a series, sex and age, the gender and the age. So gender here, if you see F7, F7 is female 7, M7, male 54, M33. So now in this case, what we see, we have the gender information as well as the age information clubbed together, right? And there is no F7, there is no splitter here. Like they could have used, if had they used underscore, my job would have become easier just using a split. But in this case, so this is the case where the extract will come into handy. And extract will use your regex. And based on that regex, what it will do, it will check whether that group is present in this item or not. Like if you see in this case, what are the possible values here? This can take M or F, right? It can be either male or female, the first character. And the second character will be the age, right? So age meaning it will be a number. So it can be a percent D. So we'll see how it is represented. I'll show you the regex part a little bit. So in this case, what our task is, what we want to do actually ideally is we want to separate out these two things. So we want to create two columns, one column with male, with gender, which will tell whether it's a male or female, and the other column which will tell the age. So if you want to separate these two out, now how can I do it? So I can extract. So for that, the extract method will come into handy. So this is how the data is. So now in this case, how many groups we have? We have essentially two groups, right? One is the gender, other is the age. These are only two groups. So for that, we can create a small regex here. So, and the groups. So if you see here, right, this is the brackets, starting bracket and closing bracket. So that is one capture group. And if you see the second one, %D here, this is the second capture group. So the first one says MF. And in the square brackets, it means either M or F. If any of them is present, it will take that as the first group. And %D star. So any number of numbers after that. Once we have M or F, if we have any number like 2, 3, 2, 1, 2, 1, 2, so it will take it all. And then we can just simply, so this is the regex that we have created. And now from string, we have to call the extract method. So what it will do, extract, so it will extract these two groups and it will, so based on number of groups that you provide, right? Based on that, it will divide your sex. This sex age is the data frame, right? This is one series. So it will break it down to F and 7. So now we have these two separated, right? Using extract and using the regex. I'll just run it. Yeah, and now I hope this is clear, right? The extract part and using the regex. I think regex, a few people who are not comfortable with may have to deep dive into the regex, but it is very powerful tool. And good to know. Not everything, at least the basic part, right? The capture groups and the optionals conditional star means for all, %d means for numbers. Yeah. So if you can see here 0, 1, so two groups are created, right? Because here we have 1 and 2, two groups here. Now let's see one more example, which is a little bit more complicated than this, but a similar one. Now in this case, we don't have age. In this case, what we have taken is we have a range. So again, the first capture group is same, MF. But then after that, we have the number. Then we have one hyphen, and then 10. And this whole thing is one component, right? And here we have plus also. It is 30 plus only, and here it is this. We will see how we can capture it. So for capturing, right? So first part is will be common, right? First group, the MF, either M or F. So group 1 captures letter M or F. That we saw it earlier also. Now the group 2. If you see the group 2, it has two subgroups. So in group 2, we can have first group %d, and this curly braces means 1 to 2, either one element or two, like the numbers, the range. It will be of 2 digits only, most likely, up to 99. So it can have either one number like 1 to 99. So it will capture the first /d 1 to 1 or 2 numbers, hyphen, then /d 1 to 2 numbers. Or either it can be this group, right? Or it can also be something like %d 1 to plus this condition, right? Here it is like this. So either it will be in the range like this, or it will be saying 30 plus, something like this. So these are two different categories, right? It can be 2A or 2B. So this pipe, if you see in between, right? That is the line, the straight line, the pipe. That means or. So either this or that, and then /plus. And same way, then subgroup 2, 2A will capture the 0, 0 to 0, 0. So these values, right? 2 digits. It can be from 1 to 199 or anything. And the subgroup 2 will capture this 0, 0 plus, this 30 plus part. So now we'll see. And what will happen? So now there are 4 here, right? 1, 2, 2A, and 2B. So now we'll just pass this regex here, and we'll just try to see an extract. So how it will be? This is 1. This is 2A. This is 2B. So you can see how it has broken it down. This is the first one. This is the second one, the whole thing. 30 plus this. So either it will be this and this 2A. 2A is the first part, and it doesn't have this plus, right? If it has plus, then this will be it. This is the whole of the item, right? The 2. And now this is 2A and 2B, the component inside it. So it will have either one of these two, not both of them, right? So this will be NaN, and this will have some value. Where this is NaN, this will have some value. Yeah. So now after breaking it out, whichever we need, we can just keep that column and remove the other ones, because it is duplicated here in some way. If you see that, we can do later processing as we want. So this was about the string manipulation, how you can manipulate string. So we saw extract method, and we saw mainly concatenation and extract with the regex, and yeah, the expression, and the normal split and concatenation, split and replace. So that is how to do it in data frame mainly. Yeah, so now I'll go to the next and today's last notebook, which is a bit longer. Yeah, so this is actually a concept here. That is important. Till now, what we were seeing was like a basic introduction, like understanding how NumPy, Python, and Pandas, right? How we can use, manipulate, and do some syntactical things is what we went into mostly, right? Like merging, concatenation, string manipulation, assembling data. But now these concepts we have to use for what purpose? That is very important. Now, so this is one important topic here, tidy data. So it is not just like we are saying data should be clean, tidy data. So tidy data is actually a concept. So we'll see how and what it talks about. Because usually when you see data, right, data, if it is clean, it will be formatted in one particular way, right? If you see the SQL tables, they are the unstructured data, right? So they have a structure. Even though the tables are for maybe employee or maybe for some grocery items, but they will have some structure, so it is organized in a way, right? But if you see some data which is unstructured or completely messy, so it can be messy in multiple ways, not like only one thing is missing or one way. Like the way it can be messed up will be many. So based on different scenarios, we'll have to use different approaches to bring the data to a state which can be used by our further model processing training, right? For that. So, so there's a paper about this which explains it. There's a link to it here. This Hadley becomes paper tied data, where they have explained the concept what data we will call a tidy data, and what are other kinds of data. So we'll come to that, but because each data will have some semantics and some structure, right? These two things will have. Like if you think of a SQL, if you have a table has some columns and rows, so that is the structure. And the column values, the values that we have, right? Each row and column will have some values. So those values are we have some meaning, right? Like if it is an employee table, so it will have employee name. So it has a meaning that it is the employee's name, or it is the employee's age. So that is semantics. So let's see now the next part. And the thing is, most of the time, like if you are into artificial intelligence or machine learning roles, so most of the times for data scientists, they spend on cleaning data and preparing it for further processing for the AI and engineers, so that they can use it for training, because the data is not ready always. Uh, it's not ready in the format that we want or that the model is expecting. So let's see how we can make a data into a tidy data, and we'll see what tidy data means exactly. So first, this NP is not required, I guess. I'll just do it. Yeah, so this is our repo paths. So this is the main repo path, SP repo path that we are using mostly. I think this is in few places it might be used. We'll see. Yeah, so we'll see what initially the data structure. So data structure means the physical layout, right? How a data is structured. That is the structure of data. Like this is like year, Australian. Yeah. Now the data can be structured in same data can be structured in multiple ways, right? It's not like only one table will represent one data. So the same set of data can be represented in multiple ways in multiple forms. So we'll see that how that can be done, how that is done, and what is the ideal way that we should do for this tidy data concept. So here, let's take some data here. This structure. So we'll so generally it will be table and rows here, right? And we'll show two ways how data can be structured in two different ways. So first one, if you see here, so it has data, so data frame only, right? So this has one. So this is first entry for the year table 19, 20, 21. So if you see all have 19, 20, 21, this is the indexes 19, 20, 21, 19, 20, 21, and this is giving the mapping. What does 19 mean? 2019, 20, and this is the winner who won, only a winner for French Open, US Open, Wimbledon. Now, if we just take this typical data in the same way, if we just pick it up and make this year as index, so what will happen? So 19, 2019. So what will happen? It will replace it here. We'll see how it will do. I did not run data. So once this data is here, yeah, you can see all these are the series, right? Because a data frame is what essentially a collection of dictionary of series. So this is one series here. It's Australian Open. So it has 19, 20, 21, and yeah. So here we have done this index also. And if you don't set index as year, in that case, this will be the index that we have here. This 19, 20, 21, 22. These will be the index. But now what we have done here, we are setting the index as year. So that's why it has formatted in this way. Here we can see this data as here. So this looks okay, right? Data usually, if you see data set, and this is actually the compact form. I must tell you one thing, it's most likely a compact form. So, and if you want to make any observation here, we are going in tutorial we can all make it, and we don't think deep into that, right? But we think. So, what is this value? This is the value, right? No, Djokovic. This is the value, and these are the variables like year and Australian Open. So if I say 2019 and Australian Open, these two things, then my result, this is my observation, right? He Novak won that year. Same way here. But this row doesn't have only one observation. So it has, this row has four observations, right? 1, 2, 3, 4 for year 2019. So yeah, so keep this thing in mind, because later this is what we will change. Because when we talk about tidy data, we should have only one observation per record. So that will come, we'll come to later, but I'm just giving you an idea, because here we have four, if you see the values, four observations are there in the same row. But it is a compact form, because if you want to see the data, we will want it to be in compact form, right? If we make this, if you convert this same table, so 1, 2, 3, 4, 4 by 4 into 16 items, because ideally each observation, so there are totally 16 observations, right? If you see 1, 2, 3, 4, and 4 by 4, 16 observations. So if we convert it into 16, it will means we'll have to scroll up and down, right? That is a thing. So that's how we usually prefer data when we are displaying it to people, presenting it. We want it compact. Yeah, but in case of machine learning things, it is a bit different there. We'll come to that part. So yeah, so this is the one way, right? So other way, what we can do is we can that's the simple part, is we can just transpose it. So transpose, I think people might know about the matrix transpose, right? Converting like 2 cross 3 matrix into 3 cross 2, changing rows and columns. That is called the transpose part. And for machine learning and AI things, I think the matrix multiplication and matrix is something that I think people should be comfortable with. So just a pointer here. Yeah. So now let's see the data restructured. So what we are doing here is we are just transposing the same data. Now the year will become column. So 19 Australian Open. Yeah. But it's still essentially that's it, we have transposed it, but still the observation units are like this only. Now let's see. Same data. Yeah. So you can see, right? This is what this line is saying. So these are the values here, the observation units. This is our observation unit, right? One record essentially, one observation unit. So now let's go to the semantics. So this was a structure, how it can be structured. Semantics a little bit I gave you an overview, but same thing is being mentioned here also. So what does a data set will ideally will contain? Suppose if you do any experiment, like in college or schools, you might have done some lab experiments, chemistry or something, or physics. So in that experiment, what you do, you take one input, then one input, and then put the output, right? The observed values for this X, for this Y, this was a Z, something like that, right? So so a data set will have variables, like, so which is varying, and its realized values. So variables will have some values, and that has to be measured across observations. So observations, when we talk about, right? So observations is like a record, one row. Think of observation as row or the value. So here, if you see, right? So values are organized in two ways. First thing, every value belongs to one variable. One variable will have one value and an observation. Like for a variable, so in this case, if you see the variable here, this here is a variable. So Australian Open is a value, right? For this value, it has realized value. And now for this, we'll have some observations. And this is other variable here, 2019. And this is the tournament, Australian Open.
Actually, Ravi,
Yeah.
the table above
Hmm.
is not organized in the correct
Properly,
way.
yes. Yeah. No,
So
yeah. We will
actually,
organize it later. Yeah, we can't say it here properly. Yeah. But these will be the
so
realized, means the observations, right? These
yes,
16 other
Australian
observations.
Open is not a
Yeah.
value. It's not a
It's a
value.
variable. It's a variable, right?
Yes.
Not now, because it's a tournament. So it is changing. It has four values. Year also, it is also changing, but it has some fixed things. So we'll see how we reorganize this so that the observation becomes unique here. So let us restructure it based on these things. So how we can make out, right? Year tournament. So we have the year value. So one variable is year. So year with values from 2019 to 2022. Like here, if you see year, this is the values. And second is tournament. So tournament also we know has 4 values. It's and player is winners of from tournaments. So this is a player here, the third one. So 3 things are changing here, right? But this will change based on year and tournament. So these 2 are the main things here. So winners for every combination of year and tournament are recorded. Okay. So now we can change the data, restructure the data in a different format. And let's see how we are doing it here now. So this is the restructured data. So we have year from 0 to 15, from 19 to 2022. And the second variable is tournament. Now this will get repeated here. Okay. Because tournament 1 to 4. Yeah, this Wimbledon. So I told you 16 entries will be there. So same way for each other winner, right? So for 2019, we have 4 times because in 2019, 4 tournaments happened. So all 4 tournaments. Again, 2020, 4 tournaments happened. All those 4 entries, same 21, same 22. So that's why we have these tournaments here. This has to come this way only. And the winners, the list of the winners for each of these. And if there's no winner, then that will be NaN. Not applicable. Maybe the event did not happen or something else, some problem. That will come to later. But if we restructure data, we can see that very easily. But here, if you see NaN is there, yeah, here if you see that NaN. So one NaN is here, one NaN is in this place. It is scattered here and there. So once we organize the data, right, restructure the data, you will see this NaN will come into only one column. Yeah. So now you see year, tournament, and winner. So year anyway is there. Tournament will also happen. Now you see winner, NaN, NaN, NaN. So what we did, we converted that 4 by 4 table into now 16 entries here, because this is our main observation. The whole thing will be an observation. So now, yeah, one thing what it made easier, like now my not a number, right? It is in a single column here, like in the winner. So now it becomes very easy to see, right? What happened, what might have happened. So I can guess like in 2020, maybe this event did not happen or it was a draw is a possibility. I can just directly say it. Just having a look at here. The same way here, maybe we have taken the data in 2022 and these events have not happened yet. Maybe they will happen in the future. That's one possibility. So same way you can make at least some informed guess, and then you can verify it based on your data because you know the source of data and the date.
In
The data has been.
2020, it didn't happen because of COVID.
Okay.
Wimbledon.
Yeah, based on data, we'll know. Yeah, that's it. Yeah. So now, what is a tidy data actually? So this data, if you see, is we'll come to it now. Let's formally describe this tidy data. So data organized in a tidy format should possess an easy link. One thing is there should be easy link between structure and semantics. So we talked about 2 things, right? The table structure and what is the meaning of data. Or if you have to take out some meaning from the table, it should be very easy link. So one thing is variables. So we talked about variables earlier, right? Year and tournament. These 2 were the variables. And apart from that, the other observation, the value that we have. So each column, like if you think of series also, each column will be one variable, will be of same type most likely. So either it will be a name, age, like in this case, tournament or tournament winner, year. And each type of observation unit forms a table. And each observation forms a row. So this row, right? So this whole row will be one observation. The actual realized value of all the variables, right? So this is one observation, this is one observation. And if you combine all these observation units, then it forms a table. Okay. So you got the point, right? So this is one variable, this is one variable, this is one variable. And usually like this is, think of it as one pandas data series, pandas data series, totally combination as a data frame. Yeah, but this is the main thing that you should remember. This part, each variable forms a column and each observation forms a row. Now we can see if after we arrange the data in proper format, right? Now what we can see that the winner of one tournament of 1 year, right? This is what is being observed. For one tournament out of 4 tournaments for 1 year, for every year, one of the 4 tournaments, one person will be the winner. So, and each column is a variable. So these 2 things. I hope this is clear now, right? At least the tidy dataset, what we call tidy here. So this is the main thing, main component of it. Now, if you have to tidying the messy data, so we talked about messy data, it can have multiple formats. So how we'll clean that up? So there are a few concepts here for cleaning the data and changing a few things. So we'll see. So we'll cover mainly these 5 types of the most encountered use cases. So like first one is like column headers are values and not variables. So instead of being variables, we'll have some values. I'll show you in the first one itself in the data set. So instead of saying like tournament or age, so I'll just show you this quick peek here. Yeah, you see. So instead of having a name here, they're given a range, salary range here, the income range. So now, and other is the multiple variables are stored in one column. We will come to all of that, and then the variables are stored in both rows and columns. In both sides, in rows also they have stored some, and in column also they have variables. And then multiple types of observation units are stored in the same table. Like in the same table, we have 2 different units. Like I'm taking the employee let's say example, the employee age information, and then employees salary information, or you can say employees extracurricular activities, other things. So 2-3 things is combined into one table altogether. So that then in that case we want to split the table into separate parts so that we can identify each unit separately. And a single observation unit is stored in multiple tables. So let us now see also, these are 5 cases that we will cover here and see how we can do it. And for these, for cleaning those data, right, for tidying it up, so we can use few concepts here. So one thing is a melt. We will come into this melt and pivot and gather columns into rows, from columns to rows, and cast, pivot, spread, or means columns to rows and rows into columns. So we'll see that nature below. And string splitting, like we did earlier, right? String manipulation, we splitted some string and then we converted one column to 2, or by concatenating, converting 2 columns into 1. Yeah, so I'll go one by one. So this is the first one. The column headers are values and not variables. So we are taking one pure data set here, which is in the US side. The relation between the income of people and the religion of those people. So based on that, there is some Pew Research Center which has created some data set in so this is about US only. So we'll just first load this data set and we'll see how it looks. Right, so this is the religion. So this part looks fine. So it has agnostic, other things. 1, 2, 3, 4, 6, 7, 8, 9, 10. How many are there? Yes, 17. So total, yeah, 18 entries are there in religion. And then if you see, this is a salary range, so less than 20K, this is the value, same way, don't diffused for all these different ranges. So instead of that, it would be better if we can convert this to. So let's see what we can do with it here. Right. So if you see these columns, right, 10K to means all the columns that we have, most of the columns except this religion here. All the columns are like what they are like values, right? They're not like variables. They have some range here. Now, if you see in this case, so we can compare our data set with this structure, right? This data frame. Like we have A0, B0, I'll tell you what is here. Like this. For this agnostic, this range, for this agnostic, range 2, range 3, range 4, range 5. So that's how it is, right? Range for the same thing. So if you see for each one, so if you take A0, for that we have range B0, B1, B2, like that we have, right? And then we have these entries for A0, B0, C0, for A0, B1, C4, for A0, B2, we have C8. So one thing is there is one concept called melting the data. So in this case, right, if you see, if you have to melt this data, this is compact. So this is a small compact form. So let's see what are three variables here. If you see one thing, one more thing, one detail I'll take. So this is the range. So this is like one variable here, right? That is changing, if you see. And apart from that, religion is another variable that is changing. And what is the third thing that is changing? Third thing are these values here, all these values, right? So these 3 are the main variables here if you think about it, right? Religion is one. This is the income group, or we can say income range or income group, and this is the count, number of people. So if you can see a count number of people in that category. So these are three main variables here if you think about it. This is what we are saying here. So if we think in this way, so what each record, each observation, if we think of tidy data, what it should be a record of frequency of one range of income per religion, right? Based on religion, for that one range, there should be a record. Right. So if we have, and it like in this case, right now we have a lot of income ranges, right? So what we have done, we've taken a smaller set, B0, B1, B2. Think of it as the range of the salary. Okay. And this is as a religion, A0, A1, A2, A3. So we have only one entries of it, right? Currently. But, and so totally, if you think of this, this green part, right? This is actually the frequency, right? This is actually the value. So if you think, so these are the, so I can say, so this, based on this, I can say this is the number of observations, right? Total number of observations will be equal to this only, right? If the observation will have more variables, right? But this is one variable I'm saying, right? So now based on this count, it's just, so in melting data, what will happen? We'll convert this row and column into this format. Like we'll take this A0, A1, A2, A3, right? We will take it for each of the column. We'll take it for B0 first. So we'll take all these four, A0, A1, A2, A3. If you see on the molten data side, right side, it has A0, A1, A2, A3, and then B0. Then for B0 we'll do it. Then for B1 we'll do it. Then for B3, B2 we'll do it. And total C0 to C11, because it has 3 plus 4, right? 12. So we have now 12 observation units, A, B, C, 3 columns, and 12 observation units. In the same way, if you see here, what will happen? So all these values will become a separate unit, right? We'll have agnostic 10K, 27, agnostic 20K, 34, like that. So same way, agnostic third one, 60. So in this case, if you see the small data set, we have this C0 to C12, only 12 items, right? We can, and that many rows will come here. That many observations will become when we melt the data from the wide, compact form to the expanded form. So remember this part. So let's see how we do it now for this our data set. So let's take one small example first, means how to show this melting of the data, right? So what is melting actually? So do this. So it's a process of gathering columns into rows essentially. So what are the columns? B0, B1, B2, right? So these columns, we are collecting them into rows here. Like B has become one separate column and it has B0, 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 right? So rows to columns. So remember that part, melting or unpivoting or gathering. So we'll take a dummy data set just to show you this part, like how the melting is happening here. So in this case, you can see here, this is a dummy dictionary, and you can see ID ABC. So ABC are fine, like our religion in our case. And do you see column name small ABC? Though right now they look like a variable, but think of them as ranges, the values. Right now, what we have to do here in this case, if you take a small subset, this ABC is like a range 1, range 2, range 3. Think of it as that way. Yeah, but it is essentially a value, right? If it is 0 to 10, 10 to 20, 20 to 30, it is a value. So now if you have to melt this table, so how would we essentially melt it? So we have one ID, so A. What we'll do? A, capital A. How are the units? A, small a. This value is 1. We'll take A again, and then we'll take B, and the value is 4. Similarly, we'll do it for all, right? So you can see here. So if we have A, B, A, C, but in this case, we'll take A, B, C, and then we'll take A for all of them. So if you see melting, and yeah, one more important thing, yeah, so I've given some pointers here. So it reshapes the data frame from wide format to long format. Like this is a wide format, right? 1, 2, 3, 4, and this is a smaller format, wide to small, and like wide in the sense the more number of columns to less number of columns, reducing the number of columns essentially, wide to long. And if you reduce the number of columns, what will happen? The number of rows will increase, right? Because your observed values count will remain same, and based on that, your number of rows will depend. So we'll see. So in this case, what will happen? So what should be the size of this molten table here? If anyone can make a guess, it's easy to guess. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Because we have 9 units, 9 items that we are observing here, essentially. The result, 9 results here, right? And based on these two things which will change. The third will also change. So this is a simple, yeah. And how do you call the melt? So on a data frame, right? If you have to do a melting, so the first thing is you will provide the data set frame that you are performing the melt on. That is the first thing. And second thing is, if you're melting it, so you're melting the columns, right, into rows. So this small ABC is what you are melting, correct? But this is what you will remain constant, right? These ID varies. So this column will remain fixed, right? The religion in our case, religion, or in this case, in dummy example, the ID. So this column will remain same as it is, right? This will remain as it is. What will change is these will have to become rows. So for that, we'll pass ID. So if there are more columns like that, in this case, we have only ID column. So this is called ID var. What we want to keep fixed. So this ID var is equals ID. So we'll set it as ID, and then only, otherwise it will be a problematic thing, right? This has to be kept constant. So this is what you have to provide. And if there are more columns, you can provide a list here. So now you can see, so it has converted A, B, C, A, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now it has 9 entries. So now we can see that each, so record this has become as a one unit, right? One observation unit. This is one unit, this is second unit, this is third unit, same way. So melting. Now let us, so this is a dummy example just to make it clear, right? How it will melt from column to rows. And what the result you should expect when you're melting. Now we'll just see the shape here. PUDF. So PUDF is our, now we are back to our problem at hand, right? This is the problem at hand, this one. And this concept melting this data frame is what we'll use here. Let's come to that and let's see its shape. What is shape of our actual? So it has 18 rows and it has 11 columns. So in this case, so in our case, right, ID where will be what? Will be religion, because religion is the one that we want to keep fixed, right? And the other ones we want to change. So in this case, so we can just do it as it is without passing these two also, but it's good to pass these two because what we are doing is we are setting the name of the variables. Otherwise, we set some default name. So income range. So the variable that the other one is it, name of the variable column, the column that is changing. Which column is changing here? The income range. So we are giving it a name as income range because that is the list, right? So we are making it as income range. And frequency is what? The count of the people. So 27, 12. So if you see any first example, I'll show you income range and frequency. Admit. Yeah, like first one is 27 entry, right? Yeah, it was 20. This is 27. Diagnostic. So these are so this will remain fixed. Religion is fixed. And apart from that, all the columns that we have, all the columns, right? These columns, they are getting melted, right? So for after melting, what will happen? It will become a row, correct? This whole thing will become one column. So for that, it should provide some name. So that name is being provided as income range, the var name. So let's clear the var name. So I'm giving an income range because one new row is being added here, right? Sorry, one column, the variable is being added, and the other is the value name, the frequency, the number of people in that range, in that zone. So this will just melt data. So I hope this part is clear how it is doing. And now if you can see, the count will have increased a lot. So it has 18 by 11, so 18 cross 11. I think that's how much it should be. 10. Okay, one row is for religion, right? One column is for religion. Yeah, so 18 by 10 only. These values you have to count. So now if you see agnostic, income range 27. So this has now become tidy. Now we can say it is a tidy variable. How? Because only religion is one variable, income range is one variable, and frequency is one variable, right? These are the variables. That's it, right? And for each of the variables, we know what is the value. If this is the religion and this is the income range, this is the value. So this is like one observation unit that you can say. So this is the first part of. So the concept important means molten melting concept is important to remember in case of data frame, because you might need to use it. So something to note. Yeah, second thing. So multiple variables stored in one column. So after melting data set, it is possible that more than one variable is stored in a column. We'll see that part next. So how multiple variables are stored. So we are taking one data set, which is taken from the World Health Organization, and it records the counts of tuberculosis, TB, tuberculosis cases by country, year, and demographic. So we'll see how the data set looks like. So TB cases, and there is some unnamed column here, so we are just dropping it because we don't need it. We don't need that. Yeah, so it has totally 214 rows and 25 columns. Columns are too many, 25. Let us see how it is there. So it has country, this is the country code, and I think it is for the year 2020 only for 1 year. So it has 5 rows only. Okay, that's a good thing. 5 rows, but 25 columns. So now in 25 columns, let us see how it is represented. So it is given F underscore 0 to 14. So what is F? It is gender of the person, right? Female. And this is the age range. So they are checking the TB cases among people of different age group and different gender. And then they have made a list how many cases or counts have come. So this is 0, 0. You see it? So this is talking about 15 plus. This is 1. M all. Now, if you see here, all these columns, now we need to see which has too many columns, right? 25, we can't see all columns here in this way. So if we just transpose it, then we can have a look at all the columns, right? And then we'll get a better idea. So let us transpose it so that we can see the column. Our intention is to look at all the columns here. Yeah, so now we should see, so rows have become columns. So these are, and here you can see country is okay, country is fine. But apart from country, if you see other things, right? So there is a lot of F. So there are more than one variables, if you see here, right? It has gender also and age also. So that's what we are talking about. Multiple variables, having multiple variables stored in one column. In one column, we have multiple variables. So this is the column, right? F014. We have just transposed it. So the columns are coming in as row indexes here, rows. But it has two variables, gender and age group. These two things. Now we need to, and we can see all 25 whether everything is same or not. Yeah, everything is same, right? M underscore all, M underscore all, male or female. And then they have the counts of the cases for each country. So this is a count. So let's see how we can extract it out. So what can be observed? So one thing is each column name that we have seen, right? Sex underscore age range, gender underscore the range, age range. That is one thing. And it is not tidy now because of this particular thing. So so we have to break it down. But what are the other variables here? So country is found, fine. We have the country code and that is okay, right? It doesn't seem to have much problem. But the other thing that we can reduce from it means what are the variables here? The changing things. One thing is gender, sex. It could be male or female. That is one thing that is changing. And other thing is age range. This is also changing. The 55 to 54, 5 to 14, based on that, these age ranges are changing. So these are the variables. Apart from that, the count will also should have been there. Based on country, we have the count, right? Yeah, so the semantics of the data set. So we can see each observation in the data set records a number of cases, less number of cases. That is also one thing. So these are the variables, but apart from that, the cases, number of cases is also one thing, right? That will come as one more column. So we are taking out recording the number of cases of age group and one sex of one country, of each country. Like, so one entry, if you take one entry, right? One observation unit, what should that observation unit be? We should have country, we should have the sex of the person, male or female, then we should have the age group, and based on their age group, we can say how many cases have been encountered for that particular range. So that will give us one information, right? One total unit. So now we'll do the same thing. So now we'll just convert this data into this observation unit format by using this melting and gathering. So let's see. First part is the melting, the one we did earlier, right? Same thing. So here in this case, we are passing this data frame, and the ID where what should be constant here? The country is same, right? Can remain the same as it is. And based on the country, what we are doing, all the columns we are converting to rows. So, and we are giving the variable name it as the column is a name given, and value names, whatever the values are there, that is the cases, the counts. So these are three things here. And now this column, this can be broken down into two, right? We should ideally, so that these two variables are separated out. And this is the cases. Now, if you see after melting, the size would have increased a lot. Now it has 5, 1, 3, 6 rows and 3 columns. But now still it is not giving the variable is not a single variable here, right? So now we need to break it down. So we can, for that, this part is easy one. We can just split it, right? Just like we did earlier. We expanded, right? One column into two. The same way we can do it here in the string manipulation using that. So we have this column and we take .str, the accessor we talked about earlier. And we are splitting on underscore because we know the underscore is present, right? M underscore all, if you see, M underscore all, and similarly other F. So we are splitting on that, and we are just n equals 1 means take only one. It's first underscore only. That's where we have to split. And expand equals true. So we have taken this column and we have split it on the underscore. And then after splitting, we are also expanding it. So one column will get converted into two here in this case, right? Because only one split we are doing. So and only one underscore is there. That is also there. Yeah. So now we have 0 and 1. So now these two columns. So one is only about gender, and the other is the age range. Now we can add these two columns to our and rename them also. Yeah. So we'll take the split 0 and the split 1, and we are taking it as sex and the other one as age row. And what we're doing, we are dropping the existing one, the existing column that is present, right? Here. This column, because we are replacing it, right? So this column we are dropping, and in place of this, what we got after splitting, right? Those we will add. That's what is happening here. And then we can just print out the head and we'll see how the data has arranged now. So we are just printing on top 5 elements. So now we have country, cases, sex, age group. So now the data looks clean, right? And one observation unit properly. So that was the second part. So in this case, if you have multiple variables in the same column. Now let's see the third part. The variables are stored in both rows and columns. Yeah, this is also interesting, and it's a tricky part. Yeah, so in this case, we are taking some weather data. Okay, there is some free access here. If you go to the link, you can see. Yeah, so for the exercise, we are taking a small data set, so that explanation is a bit easier. So again, the same station, New Orleans Lakefront Airport Station, and we have messed up the data a bit so that we can explain this particular thing. The variables are stored in both rows and columns for that part, but that is in dataset. So I hope this part is all clear. And there is one unnamed table. Axis 1 is column, right? So we are doing that, and finally we have this dataset that we need to work on. Now here, if you see, what all we have here: station is fine, year, okay, month, element. Element it says something element, but it is what Tmax and Tmin. So this is a maximum temperature in Fahrenheit, and this is a minimum temperature. And what are the other things? It says D1, D2, D3 up to D31. Right. So 31 entries are for days only. So for each day, it is recording it here, right? For each day. So this is also like a variable only. And if you see the other thing here, Tmax and Tmin. So we have Tmax, Tmin, Tmax, Tmin. We can only have two values here for this element. So we'll see. So this we should do something about this. And the other thing, we have to do something about this also. This day1, the 31 entries are here. For this, we can melt it. We melt it, that can be done. For this, we will see what we do. For this, there is a separate operation. So we'll come to that now. So let us see what is the observation, right, from the data set. What we can say, some minimum and maximum temperatures of each month in 2021 is measured. Okay, for the each month they have noticed. So we are seeing the month 1, month 2. It has, yeah, for 2 months, 1, 2, 3 months. Okay, it has only 5 rows, so only for 3 months. 1, 1, 2, 2, 3 tmax. Okay, 5 rows because we are doing head. Okay, yeah, we will see the check the shape of it. Yeah, to understand everything. Yeah, that I'm doing below. So it is the taking for year and months and all days, right? This is what it is doing. And the days variable, if you see, the day it is varying, right? Like if you see tournament. So tournament, if we put it in columns that we saw earlier, right? One by one as separate column, but it's a variable. That should not be the case. It should be one separate column, not like, and it should change on rows. Same way is we'll see here. So now what we are doing it here for first part id values, which will remain constant, but we have to make sure the station, the first part, right? What we have to change, station, year, month, and element, these should remain same, right, first initially, because now what we are doing, we are melting these days, these 31 days into rows like this. So these 4 will remain constant, right? So these are our id values, which should remain as it is. And the variable name, is the new variable which will get created, right? That will have day as a name, and the value which will take, if you don't provide any name, it will take value. Okay, so now we can see what has happened. So I'm just printing out a shape also. So totally 744 is the shape of it, and 6 are the columns. So earlier we had a lot of columns, right? 31 columns. Instead of that, columns are reduced now 6. So it has day 1, day 1. You see 1 month, Tmax. Now if you see, it seems okay if you see it here, right? But it is difficult to spot one thing here, that this element part that I explained earlier, Tmax and Tmin. So it is not changing a lot. It has only 2 fixed values. It's like category, right? And what they are doing is on a single date, right? For a single D1 only. For D1, we have max value and min value. So instead of having it in 2 places separately, right? Like this, 2 entries are there. So what is happening here? The station is same, year is same, month is same. Only thing, and day is also same. So only thing that is changing here is the element and the value, right? So I could have put it in the same, instead of this, I could have done Tmax 69, right here, and Tmin 59 here. That would have, it would have become a single record, right, for one day. So we'll see. That is our task now, is converting this column into row. So that is called pivoting. The first part, the melting part, you got it here, right? The T1. What we did, we converted column into rows. The variable column into rows. And the second part is these rows that we have values. We'll convert these into columns. So that is called pivoting a data frame. How to pivot on this column. So it is a reverse, yeah, reverse of melting. So melting, pivoting, MT. Remember, it's just the reverse of it. So we can compare it here. If you see this A, B, 0. So A0, A0, A1, A1, A2, A2. That's how it is. If you see here also, right? These two things are repeated, Tmax, Tmin. So we are taking this as a column. If you see the column B, C, B, C, these things are repeated here, right? And the values, if you see B0, B0. So instead of doing that, so what we are doing it now, from 2 columns, we are merging into 1, right? So if you just to understand it, right, just look at first 2 columns, first 2 rows, I mean to say, A0, B, B0, A0, C, C0, right? Now these two, I can convert the first 2 rows into 1 row. And that, because this B part, this columns, if you see B, C, B and C will become columns. Okay. Now I have A as column, then B and C as column. So what will happen? B will have B0 value and C will have C0 value. So if you see here, A on the pivoted data, A, B, C. So it becomes A0, B0, C0. So it has 1, 2, 3, 9 here. 6. Yeah, essentially 6. 1, 2, 3 columns because values are 6 only, right? And here also this. So you understand this? So A0, so instead of 2 entries, it becomes 1 because T max and T min, they are going to become column. Think of B as T max and C as T min. So on the pivoted data, if you see, A is the entry is the station, and B and C, T max, T min. So T max value is B0 and T min value is C0. Just from here. So these two columns, the first two rows, will become into one row in the pivoted data. So just the opposite of melting. So these are two main important concepts here while doing a tidy data. Apart from that, string splitting and those things are like usual things, right? But melting and pivoting is something that you should focus on even after when you're revising it, just to keep it in mind so that it becomes a habit. Yeah, so now we'll do that. So in our data set, right? So we had this pivoting part. Yeah, but in case of pivoting, there's a caveat here. So what will happen? It creates a multi-index data frame. Like we have station, year, month. These are fixed here, right? So what is changing is T max and T min. So if you see above here, so station, year, month, and even day and value. Yeah, even day. Yeah, and yeah, day. These things remain the same, but the value is changing, right? What are two components changing here? Element, T max, and value. So these two are related, right? T max and this value. So value will provide us, so we'll provide these names. So element is the first one and the value column name. These two, apart from these four, which will remain fixed, we are providing these two where to pivot. So element has to pivot and this should be the value of it. This is what is being done. So columns that we have to pivot, so we are pivoting element column and values, which values we have to transform that column name. And then just, yeah, and after that we are just sorting values based on the year and month. That's it. But yeah, multi-index, remember I just covered some time back. Yeah, I think our time, I'll take 10 more minutes. I hope that should be okay. This is the last notebook and I'm almost at the end. Not at the end, but it will take some 10-15 minutes more. Yeah, so now you can see. So this part has happened. So the pivot, one important thing to notice here. So what it will do is it will create a multi-index data frame. So based on this, these are indexes here we provide. So in station year, so if you see station year, month, and then day. So these have become indexes. So this day one values are here. But if you want to just convert it into a normal data frame, like with all the values properly, we just have to do a reset index. If we do a reset index, it will reset all the indexes and change the convert the values. So from multi-index to normal index, just do a reset index. And after pivoting, now this element, all the values are done properly. Station and this is index 0, 1, 2 and year, month, day. So you see T max and T min now have become properly. Now if you want to change anything, we can change it. Yeah, now it looks clean, right? One observation unit, like for one day of any of, yeah, like if you take any date D1, for that, this we have T max and T min, both are here because this is what we are observing, right? In a day. If you want to check the temperature, usually what we see, the maximum temperature of the day and the minimum temperature of the day, or we can have the average temperature of the day also. But if we spread these three values in 3 rows, then that doesn't make much sense, right? If you can see it in one row, one observation unit for one day based on these variables. Yeah, so now, but apart from this thing, we can do a lot of cleanup here. Like if you see, we can like year, month, and day, we can just combine them, right? We can just make it a day. Like it is January, day one means 1st of January 2021. We can just combine them into a single and then change it to date time. So that is one thing. So we'll do that and we'll see what can be done on this here. So what we're doing here is first we are removing this, the D in the D, yeah. See here, we have D1, D2, D3. So we can just remove D here, right? So first part is what we are doing, replacing D with the empty. And yeah, remember this regex equals to true is what we have to do. And the other thing is what we're doing, we are creating a new column date. So that after converting it, we'll have 1, 1. This will become 1 to 10. So we'll have numbers here, right? Because this D you can create a problem here because of string. So once this is removed, we can just do 1, 1, 1. and we can just convert date into a different. So what we are doing, we're taking the day, we are taking the month as string type, and then again the year, and we're just combining them. So we'll have date, which will contain the full date. And then, but it will be a string only. It's a string, right? But we have to perform any operations. Then it is better to have it as a date. So we're just converting it to date time format. Yeah, and if there are any null dates that we can see. So this transformation has happened. But after that, what we are trying to do is we are just seeing if there are any null dates. Then after that, I'll show you the data frame, how it has changed. You can see here, so like date is in for a few of the items, not many. These are null. So we can filter out these values. Because if we don't have date, we can't make sense of it. Because look, why is it that? Because it is 29 to 2021. If we had a string thing, right? String thing, and it will not have temperature also, because 29th of Feb does not exist. Something like, or maybe on that day they have not recorded. Similarly, 31 of Feb doesn't exist, 30th Feb doesn't exist, right? These are dates. Same way, Jan, Feb, March, April, yeah, April 31 will not exist. So now these entries do not make any sense. So we can just remove them, right? And if you have to pass, remember we can do conditions here. PD is null. Yeah. So now after removing it, we can see. So what we're doing is whether df. Now we are filtering out based on same our condition. If it is not null, then only keep it. Otherwise, remove it. So now our whether df will have only the valid dates, and then there we are sorting by date in place true. And these columns we have combined, right? Year, month, and day we have combined into date. So we can now remove it. From which axis? Axis is 1 from the column side, right? Not from row. And then after that, we are just setting date as an index and printing out a top 5 element. So let's see how it will look after that. Now we can see that it has become the table has become small, right? Tmax, tmin, station, and date wise. So now the data has become tidy now. Yeah. Now we have 2 more items here. I'll just cover them up quickly. Yeah. So multiple types of observation units are stored in the same table. Yeah. So this is also similar type, but in this case, what will happen? Yeah, multiple, like the artist information and the song rating, both the things are present in the same table here. I'll show you that. So we'll just separate them out. Right. So the understanding heading is multiple types of observation units in the same table, which should be ideally part of 2 tables. So we'll see that now how it is. So we have taken this Billboard dataset. So it contains actually week 1 to week 76, and it contains the information of the artist, song duration, when it was released, and each week what was its rating. Each week, because the song's rating will change, it will go up and down based on time series. So we'll just first take the data set and we'll see the data frame what we have. So we have 317 rows and 81 columns. So too many columns, right? Yeah. And so the 81 columns, how they are, so we can just have a look at a few of them. Yeah. We are just taking a subset. So remember iLoc, we can do is integer location 0 to 4, and this one 0 to 15, one less. So 0 to 15 we are seeing. So if you see how the record is, so we have year, artist, track, time, date entered. So these top 5 are at least okay. Means they are just one variable. But if you see here, week 1, week 2, week 3, it should be a week, right? And we can club them all week into a separate one. So these are transpose, right? So these are columns actually. So again, column 2, we'll have to melt it. So and total it is showing 81. So one way is you should verify each one, or you can check in the other way also. Like here, 81 is there. So 1, 2, 3, 4, 5. 5 are of this. 5 columns are these, which will remain fixed. And remaining 76. 76 plus 5 equals 81. So week is 76 here. So this 76 is what, if we change it, we will be able to view this data table properly, right? Right now we have to transpose it to see it, the columns. So first, yeah. So we notice that WK star. So that can be gathered, right? So that's what we'll do first. So we are melting it first. Remember melting and the ID varies. What are constants? So these 5 element constant, right? Year, artist, track, time, date entered, and the variable name that a new will come is a week, and the value name, the value that is present here, right? If you see, so that is a rating. So the melting is the same concept. So we'll just go fast over here. Melting, yeah. So now we have it is this way, week one. Now one thing is we have to remove this week one from here. We can do that, and this date entered, like week one. We'll see what all we can do. But it has few information. If you see like year, 2 pack, 3 rows down. If you see the artist will be repeated, and in few cases the song will also be repeated, because what is happening is for one song, what they have done, they have taken the 16-week reporting, right? Rating for the same song, the information is exactly same. The year is same when it was launched, which year we are seeing. The artist is same, track is same, time duration is also same. Time duration is also same, right? So what will, and date entered is essentially will be means when it entered, and after that we have week one, week two, week three, right? So these 4 are at least going to be same, repeated. So we'll see how we can, and this is just separate information, right? If we can have some ID of a song, and in that ID we can save the artist, which year it was launched, track time, track name and time, and based on that we just put ID here. Then also we can make more sense, right? Keeping the rating separate and the artist information, the song information separate. So that's why. So multiple information is merged in one table. So now we'll segregate it. So first part is done. Now let's see what's next. So melted, we have 76 rows here. Additional for each song, right? For each song we have 76 rows. Yeah. So now what we can do is we can take any one track, because the details are redundant, right? As I explained, for each track there are 76 entries. So if you see, yeah, look. So this is one track, right? We have taken one track loser. For that track, if you see, there are 76 entries. Now, what we can do here? So what we are doing is now we breaking it down into two parts. One is the song info, and other is the rating info. So first we will take the songs info. So in the songs info, we are taking the first 4 columns: year, artist, track, and time. Right. So this is fine. So now let's see how many entries are there. It will have a lot of entries. It has around 24,000 rows into 4 columns. But essentially, we know they are all repeated 76 times, right? One entry is repeated 76 times. So what we can do, we can drop duplicates, and we know there are duplicates here. So let's drop duplicates and see what happens. Once you drop the duplicates, you will see the count has only 317 unique songs are there. Okay. So now this is one table. So this can give us information about all the songs that we have, right? In our data set, all the song information uniquely that we have now here. Now we have two tables. Means essentially we are breaking one table into two, right? So now these two tables should have a link, right? They should have a common key that can identify the entries from here to there, from one table to another if you want to access. Like in the ratings, we have the song ID. Song ID is 0. Then that song ID 0 must be linked to some index here, right? 0 here. So this index is there, but this can change. So for that reason, we will add one more index here to this table. Yeah, to provide a link between these two tables, right? So billboard rating we have not created yet. We will create it below. Just give me some. This is a warning. Ignore it. I'll fix it later. Some warning is giving, but yeah, data output is correct. Yeah. So if you see, taking the length of all the tracks, and based on that, we are adding just one index here. So ID, not index. Index will be this. We are adding one ID here, identifier between these two. So now based on that, we'll have 316, yeah, up to 316, we have 0 to 16, these are IDs of songs. So one part is done, right? One data we have segregated, and instead of looking at 24,000 rows, we can just do it with 370 rows. The information can be saved in this. Now let's go to the second part. Okay. And then we are merging it. So year, artist, track time, and this, and so whatever was remaining, right? So based on the ID, we are just merging these two tables now. Now we'll have everything again. All the rows, 249028 rows. Now let's see, delete data and separate. Yes, yeah. So we have just merged it now so that we have this ID also associated, right, with all, and then we'll see what's next to do. Now we have to get the ratings out of it. The rating information. Where is the rating information? This is the rating information and week information and date entered and time. So we'll take a subset here again. And the reason we had add ID, right? So now we have the ID also here. So ID is one thing we are taking, which entered date it has entered, what is the week and rating. So these are 4 columns for the our ratings table, right? Because with ID we can make a link to the earlier table that we had created about the song artist info. Now let's get this table. So now we have this ratings TF here. So it has these things: date entered, week, rating. So rating is fine, it looks okay. ID is also fine, it looks okay. Date entered is and week. So if you see these two, we can combine, right? Instead of having date entered, we can just mention date. Like if I'm starting at 1st of January, suppose a song entered on first week of January, 1st January this year, 2025. So that is the first date. And then I can just mention the date entered, and I can just mention week 1, week 2, week 3. Or the other way to combine these two columns, what I can do, I can just have a date column, right? And I can mention first week of January, I can mention date 1st of January. Then I'll go to next week 2. Instead of week 2 and this, I'll just mention 7th of January, right? 1 plus 7, 8, 8th of January. Then plus 8, like that. I can just combine these two into the specific starting of the week date, right? That is one thing I can do. That will give, because if I have to calculate week from 1st of January, somebody asks me to calculate 10 weeks, 20 weeks, then I'll have to do the calculation, right? So this will give me a better view. So this is something we are going to do here later. First thing we are saying on not all songs, that yeah, one more important thing. All songs will not remain in top 100, right? For all the weeks. After few weeks, few songs will just roll out. So for them, there will be no ratings. Rating will not be applicable for them or NA. So we are removing those where the rating is not present. So we'll see how it changes from 24,000. So it has come down to 5,300. So many of the ratings were null, empty. Now, the other thing is, manipulating the what I told you, right? Date entered and week part. So the week we are getting the first thing is we have to replace WK because it's a string. So we get the numbers only 1, 2, 3, 4 up to 70. Now, based on that, what we are doing, we are changing the date, this time to date time. And the format, we already have this format, right? %y hyphen, if you see 999 hyphen 0911. So this is the format. We provide the format and then column, which we have to convert. And if you just convert it to date time format. Now, once you have converted into date time, now what I can do is I can add 1 week, 2 week to my fixed date, right? To date entered plus time delta. So that's what I'm doing. So I'm creating one separate column, and there I'm adding time whatever time delta is. So week, if it's 1 week, 1 week, 2 week, 2 week, based on that, the date will get changed, will get updated properly based on the combination of the date and the song entered in the billboard and then the week, combination of these two. So let's see. Yeah, ignore these warnings. I'll fix it, but the results are here. Yeah, so we can see ID, rating, and date. So we have just what we have done here. We have condensed everything into a small thing, right? 5307, because we need only ID to make a link with the song and artist. So now, and this is a billboard with the song information. So you can see we have converted that information that was present in one combined table of 24,000 rows that we have now cleaned up, and it is in 317 rows only, and it is in tidy format. The main thing is tidy format, one entry. Here the entry is related to artist and years, and there the entry is related to ratings. Now the last one. So this item should be small. So a single observation unit is stored in multiple tables. Yeah. So in this case, like, this is a simple one. Like, if you think what we have taken is the winners. like if you are taking, we are going with the example of tennis tournaments. So in this case, if we have the winner of men, so we have two tournaments, men's tournament and women's tournament, right? So if we have tables which are one table containing only the men's information and other containing the women's information, but if you want to combine these two into a single one, so like from these two to one, we can do, right? So that we'll see. So we have taken one as this is a men's list, so it has some 88 rows year wise, and the other one is a women's. So now if you see here the observation units, yeah, one more thing. It says men's, but there is no column here, which says male or female to identify. So if you have to merge these two, we need to create an identifier, right? One extra variable which will tell me that this is like just like we did for earlier, different tournament types. So here we'll add one more column here in both sex. What is the male gender, male or female? So for male we'll add male, for female we'll add female. So like if you see this in GS main data frame, we are adding male, and in the women we are adding female. So after this operation, now we have this sex column also here. Now based on this column we can differentiate easily, right? So when we combine these two tables, we'll know whether it's for men's or women's. And this is a women's TF. Now we can just concatenate these two. Means just like we did earlier, right? Concatenation, and axis is not provided here. That means along the horizontally, like 88 rows are there plus 88 rows. Rows will get added. So if you see the total, GSDF, yeah, so it will have 176 total, at least 176, and now we are done merging these two. And this noticing is like this information is required here, right? Otherwise, if you do not add this information, there will be a confusion here, right? Because for 1 year, like in this case, because this particular thing will have two entries, right? One for male, one for female. So that is the reason for adding this column here. Yeah. So yeah, that is it for today. I think I have taken some extra time, 15-20 minutes more. Yeah, sorry for that. But yeah, so tomorrow we'll be covering the 7, 8, 9, the next 3 notebooks. And for today, if you have any doubts, you can please ask. We have a team here. If there's any doubt or any clarification needed on these concepts. And there's one more lab here actually, which we have added. So you can just try to work it out. And I've added a solution also for the previous lab that you can go through. This is also a simple lab, not very difficult. Yeah, so I'll stop the share and I think we'll see.